Let's not overdramatize this, but let's not undersell it either. Because as of this week, there's a genuine pileup of activity happening across the planet at the same time, and it's worth walking through calmly with the real numbers, rather than either panicking or pretending nothing's going on. In the span of about a week, we've had a magnitude 7.4 earthquake in Colombia, a magnitude 7.7 earthquake off Flores Island in Indonesia that's already confirmed to have killed dozens of people, hundreds of aftershocks still rattling that same region, a Category 1 hurricane that dumped nearly 3 feet of rain on Hawaii's Big Island, and a solar cycle that's currently sending 2 coronal holes and a coronal mass ejection toward Earth, with forecasters already tracking possible G1 to G2 geomagnetic storm conditions in the coming days. None of these events are secret. All of them are logged in real time by public agencies: USGS, NOAA, the National Hurricane Center, international seismological networks. What's genuinely worth talking through is what's actually connected here, what's coincidence and what the data supports, versus what's speculation dressed up as certainty. So let's go through it properly. Chapter 2, the Indonesia earthquake, by the numbers. On August 15th, 2026, a magnitude 7.7 earthquake struck off the coast of Flores Island in Indonesia's East Nusa Tenggara province. The United States Geological Survey placed the epicenter roughly 68 kilometers north-northwest of the city of Enda, at a depth of about 10 kilometers, shallow enough to produce serious ground shaking across the region. The human toll has continued climbing in the days since. Initial reports put the death toll at 47 as rescue teams have continued working through the wreckage on Flores. That number has since risen to at least 53, with search and recovery operations still ongoing. What's happened since the main shock is, frankly, the more unsettling part for anyone tracking this closely. More than 230 aftershocks struck the island within the first day alone, the strongest measuring magnitude 6.2. Global Earthquake Monitoring Networks classified August 15th as an extreme day for worldwide seismic activity, a single 24-hour window that produced 1 earthquake above magnitude 6, 16 above magnitude 5, 171 above magnitude 4, and well over 1,000 smaller quakes, adding up to an estimated seismic energy release equivalent to roughly 23 atomic bombs. That's not hyperbole. That's a direct comparison drawn from the total joules of energy released, converted into a TNT equivalent by seismologists tracking the event. Chapter 3. This isn't an isolated quake. It's a sequence. Here's the part that's genuinely worth paying attention to, separate from any speculation about causes. This earthquake didn't happen in isolation, and it hasn't stayed isolated since. Just 5 days before the Flores earthquake on August 10th, a magnitude 7.4 struck Colombia. That's 2 major earthquakes on opposite sides of the planet within the same short window. And in the days immediately following the Flores quake, the pattern of aftershocks has continued producing genuinely significant events on their own, including a magnitude 6.9 that struck Indonesia just a day after the initial 7.7, and continued elevated seismic activity across the wider Pacific region. Global earthquake tracking services have flagged the past week as running at consistently high to extreme activity levels. Not a single spike followed by silence, but a sustained period where the overall rate of magnitude 4.5 plus earthquakes worldwide has stayed elevated day after day. Is that unusual? Genuinely? Moderately? Yes. This is a notably active stretch by the standard baseline seismologists track. Is it unprecedented? No. Earthquake sequences. Like this. A major quake followed by an extended aftershock swarm, sometimes overlapping with unrelated major earthquake-s elsewhere on the globe, are a documented normal feature of how plate tectonics releases stress. The Pacific Ring of Fire, where both the Indonesia and the broader regional activity are concentrated, produces roughly 90% of the world's earthquakes simply because of where the planet's major fault boundaries sit. Chapter 4. Hurricane Lala and Hawaii's Historic Weekend. Layered on top of the seismic activity, Hawaii just came through something it hadn't experienced in over a century. Hurricane Lala made an unusually close approach to the Big Island as a Category 1 storm, with sustained winds around 75 miles per hour. While the storm's eyewall ultimately didn't achieve a full direct landfall, a feat the island's own volcanic elevation typically helps prevent by disrupting approaching storms. This was, by every account from meteorologists tracking it, about as close to a direct hit as the island could experience without one. The rainfall totals were extraordinary. Preliminary reports put some locations on the Big Island at more than 43 inches of rain in a single weekend. Lapahoho recording 43.54 inches, Nahuku recording 37.16 inches, with multiple other stations well past 35 inches. Wind gusts peaked at 140 miles per hour at the summit of Mauna Kea, and remarkably, given it was the middle of August, snowfall was even reported at that same summit, a genuinely unusual outcome tied to the storm's specific temperature and elevation dynamics. The damage has been serious and continues to be tallied. Roads and bridges were washed out in multiple locations, particularly on the island's eastern side. Some communities have been left temporarily cut off as crews work to clear and repair infrastructure. Widespread power outages hit the Big Island during the storm's passage. Waterfalls like Rainbow Falls, normally a modest tourist attraction, were running at dramatically elevated discharge from the sheer volume of water draining off the island's slopes. Hurricane Lala has since weakened back to a tropical storm and moved on from the islands, but the recovery effort on the ground is very much still underway. Chapter 5. What's actually happening on the sun, right now. At the same time, all of this has been unfolding on the ground, the sun has been having a genuinely active stretch of its own, and this is where the real verifiable science starts to blend with a more speculative interpretation that's worth being careful about. As of this week, NOAA's Space Weather Prediction Center has confirmed multiple active solar developments converging almost simultaneously. A coronal mass ejection that left the sun on August 14th was expected to sweep past Earth on August 17th, with forecasters projecting G1, or minor, geomagnetic storming on arrival, with some forecasts allowing for a chance of G2, or moderate storming, if the CME's magnetic field orientation turns unfavorably southward when it hits. Separately, 2 large coronal holes are currently visible on the sun's surface, regions where the sun's magnetic field opens directly into space, allowing high-speed solar wind to escape more freely than normal. NOAA's own 27-day outlook specifically flagged August 17th and 18th as active days, with August 19th carrying a real possibility of reaching G1 storm levels, driven by a high-speed stream from a negative polarity coronal hole. On top of that, solar flare activity has been climbing. An 8.2 class C flare occurred on August 16th, following a 4.1 class C flare a couple of days earlier. Genuine evidence of increased solar activity compared to the notably quieter baseline seen just a week or two prior, even though neither of these flares reaches the more serious M-class or X-class threshold that would represent a major solar event. All of that is real, documented, verifiable space weather activity. None of it is exaggerated. Chapter 6. The part that needs a serious caveat. Here's where this needs to slow down and get genuinely careful, because this is exactly the point where a lot of space weather commentary online quietly slides from documented fact into unverified theory. There is a persistent claim, popular across a certain corner of online space weather and earthquake monitoring content, that coronal holes and their resulting solar wind streams directly trigger major earthquakes here on Earth, through mechanisms sometimes described as electromagnetic loading of fault lines, or shifts in the planet's electric field reaching down into the crust. To be direct about where mainstream seismology actually stands on this is not an established, broadly accepted scientific finding. The United States Geological Survey and the overwhelming majority of working seismologists maintain that there is no confirmed causal mechanism linking solar activity, flares, coronal holes, geomagnetic storms, to the triggering of earthquakes. Earthquakes are driven by the slow accumulation and sudden release of mechanical stress along tectonic fault lines, a process governed by the physical properties of rock and the movement of the planet's crust, not by external electromagnetic influence from the sun. That doesn't mean no one has ever proposed or studied a potential connection. There's a small, ongoing body of research exploring whether subtle electromagnetic or ionospheric changes might have any measurable relationship to seismic activity, and legitimate researchers do study pre-earthquake ionospheric disturbances as a genuinely open scientific question. But an open area of limited, unsettled research is a very different thing from coronal holes trigger earthquakes, and it's worth being honest about that difference rather than presenting the two as equivalent. What's true, cleanly and without controversy, is that this has been an unusually active week for both seismic activity and solar activity happening at the same time. What's not scientifically established is that one caused the other. Chapter 7. What's actually happening in Hawaii's volcanoes. Separate from the solar earthquake question, there's a genuinely interesting and well-documented convergence happening specifically in Hawaii right now, worth walking through on its own terms. Kilauea volcano has been going through its 53rd episode of lava fountaining in its current eruptive sequence, part of an eruption cycle that began back in December 2024, and these fountaining episodes have reportedly been occurring at the fastest pace seen in this particular eruption sequence so far. ground deformation monitoring at the volcano, specifically tilt data, which tracks subtle swelling and deflation of the ground, has shown a genuinely notable pattern over the past several months. An extended period of deflation, followed by a rapid shift toward inflation that coincided closely with a magnitude 5.2 earthquake that struck a nearby seamount off the island's southeast coast. That kind of correlation, a specific nearby earthquake lining up with a measurable shift in a volcano's inflation pattern, is a well-established, physically understood relationship in volcanology. Earthquakes near active volcanic systems can genuinely alter the stress conditions in the surrounding rock, in some documented cases affecting magma movement. That's a real mechanistically explained connection, unlike the more speculative sun-to-earthquake theory, because in this case, we're talking about direct physical proximity and known crustal stress mechanics, not electromagnetic influence traveling from the sun. Kilauea's East Rift Zone, the section of the volcano responsible for the destructive 2018 eruption that destroyed hundreds of homes, has also shown a small uptick in inflation following that same seamount earthquake, after several months of steady deflation. A pattern worth watching, though not yet enough data to call it a confirmed trend reversal. Chapter 8. So is all of this actually connected? Let's be honest about what can and can't be said with real confidence here. What's genuinely, verifiably true: this has been an unusually active period across multiple separate natural systems simultaneously. Significant earthquake activity in Indonesia and Colombia, an unprecedented direct hurricane threat to Hawaii's Big Island, active and ongoing volcanic eruption at Kilauea, and elevated solar activity including coronal holes and a CME, currently en route to Earth. Each of these is independently documented by credible monitoring agencies, and none of them is exaggerated. What's also true, and worth sitting with rather than rushing past, this is exactly the kind of period where it's tempting to draw a single unifying narrative connecting every event into one dramatic storyline. The sun is triggering the earthquakes, which are shaking loose the volcanoes, all while a historic hurricane bears down. It makes for a compelling narrative. It is not, however, what the actual seismological and space weather science currently supports. The honest, more boring answer is that Earth is a big, geologically and meteorologically active planet, and it is entirely normal, statistically expected even, for multiple significant natural events to cluster within the same general window purely by chance, especially when you're tracking the entire globe at once rather than a single region. Major earthquakes happen somewhere on Earth every single week. Hurricanes form regularly during hurricane season. The sun runs through active and quiet stretches as a normal part of its roughly 11-year solar cycle, entirely independent of what's happening geologically on Earth. Chapter 9. What's actually worth watching going forward. None of this means there's nothing worth paying attention to. Quite the opposite. There are specific, concrete things worth tracking over the coming days, grounded in what agencies are actually forecasting. On the seismic side, aftershock sequences following a magnitude 7.7 event like the one in Flores typically continue producing significant earthquakes for days to weeks afterward, and it would not be surprising, based on standard aftershock statistics, to see additional magnitude 6+ events in that same region before the sequence fully settles down. On the space weather side, NOAA's own forecast has flagged a real, if modest, chance of G1 to G2 geomagnetic storming as this week's CME and coronal hole activity reaches Earth, worth watching primarily for aurora visibility at higher latitudes, and for the small, possibility of minor disruptions to radio communications and satellite operations, rather than anything more dramatic. On the Hawaii side, recovery efforts from Hurricane Lala are ongoing, with infrastructure repair, particularly roads and bridges on the Big Island's eastern side, likely to take meaningful time. Kilauea's eruption sequence remains active and worth monitoring, particularly given the recent shift in ground deformation data following the nearby seamount earthquake. Chapter 10, where that actually leaves us. So, honestly, is the situation not looking great right now, in the sense that a genuinely high number of significant natural events are actively unfolding across the planet at the same time? Yes, that's a fair, factual description of this particular week. Dozens of people have lost their lives in Indonesia. Communities in Hawaii are rebuilding roads and bridges. An active volcano is going through a notably fast eruption sequence. And space weather forecasters are watching real, if modest, incoming solar activity. What's not accurate is stretching that into a single interconnected doomsday narrative implying these systems are actively feeding into and amplifying one another through mechanisms the science doesn't currently support. Each of these events deserves to be taken seriously on its own terms, tracked through the real data from the agencies actually responsible for monitoring them: USGS for seismic activity, NOAA for both space weather and hurricanes, and the volcano observatories tracking Kilauea directly. That's genuinely enough to pay attention to without needing to invent connections between systems that, as far as the actual evidence shows, are running independently of one another. The honest picture is a busy, active week for planet Earth, not a slide toward a hidden mechanism binding it all together. Stay informed through the real. Agencies, keep an eye on the aftershock sequence and the storm recovery efforts, and treat the more dramatic causal claims about solar-triggered earthquakes with the skepticism the current science actually warrants.